Okay, so we were discussing this example. So we were discussing that in this category there are monomorphisms which are not injective. Okay. Now consider this. Consider this natural map. Now consider the
सर ये जो आपने NH इज इक्वल टू जी बोला ना,
yes,
इसको हम कंपोज करते हैं बाय ग्रुप कंपोजिशन और बाय मल्टीप्लिकेशन.
ग्रुप कंपोजिशन H को ऐड करना है n बार. ठीक है, ये
यस
एडिटिव ग्रुप है ना. ठीक है.
यस सर
हाँ.
यस सर.
Now consider the natural map. Natural map, it is also a homomorphism Q to the quotient Q by Z. Okay, so it is a group homomorphism, so it is a morphism in this category. Now you can see that. Now choose 1 and -1 belonging to Z. Of course, you can see that this mapping is actually not injective. I am particularly taking 1 -1. In fact, it is true on any integer n. 1 is not equal to -1, you know this, but 1 plus Z is equal to Z is equal to -1 plus Z. ओके, ये किसी भी n के लिए ट्रू है, किसी भी इंटीजर के लिए ट्रू है. किसी भी इंटीजर के लिए उसका नेगेटिव डिस्टिंक्ट है बट उनका कोसेट एक ही है, 1 प्लस जेड. किसी भी इंटीजर n और माइनस n के लिए n plus z is minus n plus z, but n is not equal to minus n. So this means what? This mapping is this natural map is here is not injective. Okay, so let us call this f. So thus f is non-injective. F is not injective in this category. However, f is a monomorphism. However, f is a monomorphism. I will show that it is a monomorphism. Okay, to see this, let G be a divisible abelian group. So let G be a divisible abelian group, and say G and H, small g and h from G to Q be two morphisms such that F composition G equals F composition H. Our aim is to show that G is H. Okay. Let L, I am taking the difference of these two morphisms G minus H, because the groups are additive here, so I can take L as G minus H, which is also a morphism, which is also a group morphism, which is also a morphism. Okay. Now if you take F composition L, it is actually F composition G minus H. So it is F composition G minus F composition H. So they are same, so it is 0. So F composition L is zero morphism. This 0 is actually a zero morphism. Okay, so now you have this situation now. From G to Q, you have L, which is G minus H, and from Q to Q mod Z, you have F. Such that this composition is zero morphism. Means what? Now F composition L is zero means what? Now F composition L is zero morphism actually implies that this L of X is an integer, because 0 of this Q mod Z is actually Z. Okay, so it actually means that Lx belongs to Z. Lx belongs to Z for all x belongs to G. Lx is an integer for all x in G. Okay, now our claim is that Lx is 0. If I show that Lx is 0 x in for all x in G, then my job is done, because then I will have G equals H. So my claim is that Lx is 0 for all x in G. So claim Lx, yes. If you have question, what is your question, please? Somebody has raised the hand. हाँ बोलो भाई, बिस्मा, आपका क्वेश्चन क्या है?
नो सर, गलती से हो गया.
So Lx, our claim is that Lx is 0 for all x in Z. So if not, choose x in G, such that Lx is not 0, such that Lx is not 0. Once Lx is not 0, then L of x over twice Lx, I can take this, because Lx is non-zero, so I can take this x over twice Lx. Okay, since L is a morphism, so it is Lx over L of Lx is actually Lx, so 1 by 2 Lx. So it is actually 1 by 2. Okay. So thus this means F composition L of this x over twice Lx. This is F composition L of 1 by 2. And this is F of F composition L of 1 by 2. So it is actually F of
L composition x by twice Lx. ये L of x by twice.
हाँ F of
ये खाली F of 1 by 2 आएगा.
हाँ F, yes, good. So it is F of 1 by 2. Okay, it is F of 1 by 2. And F of 1 by 2 is 1 by 2 plus Z, which is not equal to Z. Okay, and which is a contradiction to our earlier thing. Now here we have that F composition L is 0. Here we are getting somewhere. हमने कहाँ मिला था, यहाँ है ना. So contradiction to this one. So which is a contradiction. Okay, which is a contradiction. So so this means L equal to 0. So L equal to 0. So this means G minus H equal to 0. So this means G equals H. So F is a monomorphism. Okay. So in the category of divisible abelian groups, you have a morphism which is not injective but which is a monomorphism. So there are some simple facts I will leave for you as an exercise, so you can just take this this proposition. So it has three parts. Every identity morphism is a monomorphism. Every identity morphism is a monomorphism. Second, composition of two monomorphisms is a monomorphism. Composition of two monomorphisms is a monomorphism. And if the composition is mono, then the first one is mono. G composition F is monomorphism. Monomorphism implies F is monomorphism. F is a monomorphism. Okay, so this is an exercise, do it. And last property is that every faithful functor reflects monomorphisms. So another proposition, every faithful functor reflects monomorphisms. I will just give a brief view of this. It is just straightforward. So let us see. Now let f from f from a category C1 to the category C2 be a faithful functor. Be a faithful functor, and let f from A to B be a morphism in C1, be a C1 morphism, such that you have this, such that f of f is a monomorphism in C2, is a monomorphism in C2. We show that f is monomorphism in C1. So let G and H from C to this some object C to A be morphisms in C1, be morphisms in C1 such that F composition G is F composition H. Then apply the functor, because on home set restrictions, this I will use the fact that on home set restrictions this F is injective. Okay, so this means F composition Here I'm not applying, but on the when I will get back, I will apply. This means f of f composition G is f of f composition H. Now functor preserves the composition, so ff composition f G equals ff composition fh. Okay, so ff is a monomorphism, so it would imply that fg is fh. Now I will apply that f is faithful, so I will get that g is h. This is because f is faithful. Okay, so hence f is a monomorphism in C1. Hence small f is a monomorphism in C1. Okay, so this is all about monomorphisms. We will have some other examples or concepts related to this. Maybe we will discuss it in the next class. If you have questions, you please ask. Yes. So okay, see you in the next class.